Welcome. In this lecture, we're going to talk about what it means for a function to be well defined. In the language that we use, typically in more advanced mathematics, we don't call something a function unless it's actually satisfies the definition, which means that it's well defined. This comes into play more when you're either defining a function by a formula, and so you may not notice that you're failing one of these properties. The other is sometimes when you have something like equivalence classes and you use one representative from that equivalence class to define a function, and it turns out that if you used a different representative, you would get a different output. So that's not allowed. So this is something that you need to always take into consideration and often verify or satisfied. Okay? So first let's just recall the definition of a function. So recall the function definition. Okay, and remember in here, so we were supposing that S and T were sets. So we're supposing that S and T are sets. Right, and then we had that, so definition, so a function f, so a function f from S to T, so this goes from S to T. Right, so what did it mean to be a function from S to T? It is a rule assigning, right, to each S and S a single element, so a single element f of S, denoted like that, of T. So this was the definition, so now we kind of have to break it down a bit. So satisfying all the properties of the definition are what we mean when we say that a function needs to be well defined. So satisfying all the properties of the definition are what we mean by needing a function to be well defined, by needing a function to be well defined. Function to be well defined. Okay, so let's kind of look at that then. So then we say, so a function from S to T, right, which is the notation up there, so a function f from S to T is well defined if, so it's going to need to satisfy all of these properties. Okay, so one, we know what f of S is for every single, right, S in our domain. Okay. With the picture over here, I'll kind of do my pictures over here. So I have some kind of S in the domain, and we know where it's going to. Okay, so this is going via f to some point f of s. So you told me where each point went. Okay. And the next thing we need is that f never tries to map. So f never tries to map a single element S and S, right, to two or more different elements of T, so to two or more different elements of T. Right, so here's what we don't do, so this will be a no picture, which is that we would have some element S. So this is our picture for 1. Our picture for 2 is going to be that you don't have, so this is a no picture. You don't have that you have this S here, it's a single S, I have my T here, and then I look and I decide, well, I want to go to both that value and that value, so we don't do this. This will be a no picture. Okay. So this is a no picture. Okay, so 2 tells me I can't do that. So, and it's very dangerous to hold too many markers at a time. And okay, we have that, right, that we always have that our value S is going to end up inside of T for each, oops, I meant to do that in red, so for each S in S, right, i.e. that this notation where I apply F to the entire set, so I get the range, that this is actually contained within the codomain. Okay, so the range is contained within the codomain. So let's do our picture for 3. So our picture for 3 has 2 parts, so it has a yes part and it has a no part. So here's the yes part. So I end up with an f of s in here. Okay, so this is yes. Right, and then we also have a no picture, which would be, here's my no picture, which is that S is going to go to, maybe T somehow isn't encapsulate everything we might wish it encapsulated. And so my F, and then sometimes it's a little sneaky to figure out. We thought we were mapping our F into there, but instead it ends up somewhere that's kind of misses our T. Like I said, you know, maybe T is the integers or something like this. Then it's very possible that, you know, your output is not, it ends up a real number but not an integer. So this is my no picture, right? With the problem with this picture being that, right, it's a no picture because my output doesn't actually land in my codomain, right? I could have chosen my codomain differently so that this actually made sense, but you have to actually choose your codomain like that, and sometimes it's important. These things can be sneaky. I know, like, looking at it, you're like, oh, these things are obvious, but they can actually be sneaky to check sometimes, so you have to kind of look out for it. You can't just define a function to be anything. Okay, so I hope that made some sense and was helpful, and I will see you in the next lecture.